So, good morning once again. My name is Opeyemi Matiluko. Okay, yeah. So my name is Opeyemi Matiluko. Some may ask, what's the meaning of Matiluko? Is it Yoruba? Is it Hausa? Is it Ibibio? Actually, it's a Yoruba name. Yeah, it means Matilukuro. Matilukuro. So it's just shortened as Matiluko. And I'm glad to be here this afternoon. I appreciate the organizers for the privilege to be a facilitator in this program. I think I was a facilitator in the, this is the first one now. And I'm glad to be back here today again to present to us this topic, DevSecOps, Lifecycle Overview, and Open Source Toolkits. And I'll try to make it as interactive as possible, and I'll like cooperation also. So I might be asking questions as we go along, and I would like us to also give our responses to some of the questions I'll be bringing up. Now, as it was said earlier on, I'm from First Dynamic Links Nigeria Technologies Limited. First Dynamic Links is a software company. So I'm one of you, actually, because I was in Landmark University before I left to start the business. And I'm glad to have my people here from Landmark too. The person I handed over to as Director CSIS is here. So glad to be here. Okay, so let's just get up to what we have for this morning/afternoon. Now, the first speaker, the keynote speaker, spoke about the DevSecOps. I think introduction to that, he mentioned a few things about that. And I'll be building on what he has said for us to understand the life cycle and where does security come into play when we talk about DevSecOps. And then apart from that, some people were asking questions about what tools can you engage during the life cycle. And those are some of the questions that we'll be answering based on this session of the teaching. And for subsequent ones, we're talking about something a bit different, but still in line with this. But let us start off. What is DevOps? Anyone? You've heard about DevOps before, right? You? What about DevOps? So, can anybody talk about DevOps?
Like our key first speaker said, is that DevOps is like a cultural shift from how we used to deploy, traditionally how software was being deployed, but now it's incorporating both operations and the development together, working in synergy.
Thank you very much. That's a good one. He said incorporating both the operation part of IT along with the development part of IT. And he said earlier on that DevOps is not a role, right? Did we hear that? That it's not a role, but it's a way of life. It's a culture. Yeah. It's a way of life. So DevOps is actually not something you say, oh, I'm a DevOps. Yes, they are DevOps engineers. But in the actual sense of it, their work is either operational or development, or the other parts of development. And we'll run through some of those key things before we go into DevSecOps, so we understand all these basic principles. Now, it is just aligning the development phase with deployment phase. Some of us that started programming some few years back, if you've been programming for about 10 years now, can I see your hands up? You've been into development for about 10 years, 7 years, 6 years, 5 years, 7 years. Good. How many years? 5, 10. Yeah. Okay. Anyone 10 years? Above 10 years? Okay. Now, when some of us started programming, it was a one-man team. Are you aware of that? Now, these days, I see a lot of young programmers. They can't do anything except there's a UI UX designer that will design something for us. And after that, then the front-end guy will come, do his own part. Then I say, I'm waiting for them to finish because I can do anything. Then I say, oh, my work backend. Database, I don't deal with it. I just write to connect to it. As a one-man team in those days, you start from the planning on your paper with your biro. You plan, and then you do development beginning to the end. You are doing a web app. You are building the CSS from scratch. No templates, nothing. Just something in your head that you feel this is what I want to achieve. And then with your notepad. And then you wonder, how did you cope and survive in this age, right? Without VS Code, without Sublime Text, without, which other one? Which other IDs do you use? Yes, Cursor with AI embedded into it. VS Code with Copilot embedded into it. Yes, Atom. Now, in those days, it was not like that. You sit down, development from beginning to the end, and then you're the one that will still test your code because you are the one-man army. Now, but these days, we have what we call division of labor, whereby you have a project manager that will sit down and say, this is what we want to achieve with this project. You have a product owner that says, okay, I'm the one that defines the requirements and what it should be. You have a product designer, UI UX guys that comes, put in the design, and then when they are through, the front-end guys choose their framework, maybe React or whatever framework you have, Vue, and then design the front end while the back end is working. And then the database guy too is designing the structure of the database. Now, but the challenge comes because now you're not the one deploying, like he said earlier on. You've developed, you've tested, but someone is deploying. And you know, with the age of framework, before you know it, version 2 is out, version 3 is out, in the next 3 months, version 4 is out. In the next 5 months, version what is out again? I remember that I had one application that I developed for a client. And it was designed with React Native, a mobile app, React Native. And then we started from when React Native was on Expo SDK. Expo was on Expo 45. Before you know it, 46 was out, 47, 48, 50. In less than 2 years, we're already jumping like how many versions? And then you have to go back, update, and do that. Now imagine you now develop something with Node.js as a server running. And then on your system, you deploy using Node.js 14. You tested everything. It was working fine. You now give it to the deployment guy that go and deploy. And then without asking any question, deployed Node on the server. What do you think would happen? You start seeing a lot of errors coming up, right? Yeah. And that is why the DevOps came up to be. Where we have containerization, other things, orchestration, you design so many things, you package the application with all dependencies. These days you have package managers like what? NPM, like Yarn, right? To even define to the granular layer what version should be installed. Whether it is fixed on version 20 or anything greater than version 20 or anything around version 20 point something, right? Now, all that is to help avoid and reduce the level of issues that you have at the point of deployment. So that at the point of testing, whatever your experience, the experience you have at the point of development is the same experience you have at the level of testing and the same experience you have at the point of deployment. So that there are no guessworks or there are no excuses, there are no disappointments at the point of deployment. Now, all this now goes into the life cycle of what we call the DevOps life cycle, which starts from the level of planning. It moves to the level of coding, building, and then you go on and on. And then it goes back into planning because at the end of the day, you'll be monitoring. You see a bug, then you keep what? Fixing the bug, and you keep developing the application. Now, and with the age of agile methodology, you have a big application that you're broken down into smaller parts. You do the most important part first, right? Then you keep building on that, like a building block. Now, all this runs through the life cycle that we have called the DevOps life cycle. So, what is DevOps doing for us? One is help us focus on streamlining the development and operation life cycle, often through automation, and to deliver software quickly and what? Reliably. Now, not the word quickly. Because I was asking, do you cope with time management when you have to introduce what? Security into this life cycle. Now, all that is what we'll be looking at in this session. So, we are trying to get things to market as fast as possible, while also ensuring that quality is not compromised at any level. Now, but with DevOps, what happens is that at the point of the deployment or development, you're not talking about security. You're only after what is the end goal. What are we trying to achieve? And you're achieving that based on what has been set as what? Your requirement in the requirement document, right? Now, but at the end of the day, when you start deploying the application, they start discovering loopholes. As a matter of fact, there is no perfect application. True of us. True of us. Even Microsoft till tomorrow is still fixing bugs till tomorrow in their Windows. It comes up, you update. Even Linux, as secure as Linux is still releasing what? Updates. Even MacBook, I still get updates every now and then. So there is no secure system. But then, we try to minimize the issue of security to the minutest what? Events. So that whatever you are getting at the end of the day is something that you can't avoid at that point in time. And that is why, instead of us waiting till the end of the day, when we have developed the application and it starts detecting bugs, maybe by the time the QA guy is looking through it, he's seeing bugs in your code. We're not saying, oh, instead of that, let us start even security checks from the beginning of our operations. From the planning phase, let us plan security into the system. And that is what brought about what we call the DevSecOps. Now, this is a simple life cycle of DevOps. You can see Dev here, like I said earlier on. You see our ops, that's our IT operations. And this starts from the planning phase. And on the planning phase, you are already planning from the beginning. CI/CD into the system also. As you're defining your structure, defining your requirements, you are planning all that into the system. You are planning your coding. You are working with source code, and then you are also working with what? Version control. We'll talk about this in the next session, version control. Now, as you are building, you've coded, you've written your code, you're building, and you're using whether your Apache to deploy, your what again? Which other server? Node.js to deploy. You are automating the process also. And then you are testing through quality assurance. And then you are releasing the application. And once it's released, you are deploying. Deploying through infrastructure as a code. How many of us know what infrastructure as a code is? IAC. Okay, I think we'll talk more about that. Now, and then you are provisioning your servers also. So what IAC does is simple. Now, if you're deploying an application on Amazon, how many people has deployed on Amazon before? AWS. You've worked with AWS before, or Google Cloud, or any other. Yeah, how do you deploy? You go there, select your instance, create an instance, right? Create an instance, create your virtual private network, create every other plug here and there. Now, we're not saying instead of you doing that manually every time, when you need to scale, you now go and set your what? Auto scaling, and then set your time to downgrade when you want to downgrade. Now, instead of you doing that, why don't we have the definition of your infrastructure as a code itself, like a programmer? in such that someone else can manage the same infrastructure as you are managing. Now, right now, if you create an infrastructure, to take someone a lot of time to understand what you have provisioned, true or false. Because if you are working on Amazon, for example, probably you are deployed into a different zone. You've selected maybe Europe West, and the person logged in and is logged in into Europe East. And then you say, there's nothing here. Now he has to start going through to know where you have deployed the application, true or false. True. Now, something else that happens is this. Another way you can get is to go to billing. And then go and check where the billing is coming from, right? But that is stressful. Now, after doing that, it now needs to now go granular into your code, to into your structures to understand what kind of network you've deployed. True or false? True. Now, but instead of doing that, there's a way you can now deploy the same infrastructure, provision instances, provision network, now with code. So that you have your code in what we call YAML, Y-A-M-L. You define it, it's close to JSON, if you work with JSON before. It has a structure. You define it, and anybody else can pick up that same code, read through it, and understand the structure of your network without you having to explain to him or her. And that is what infrastructure as a code brings to bear for you. So it simplifies the process. It simplifies handing over the same process to someone else. So as a team, you can work together even on provisioning. You can work together in provisioning devices, in provisioning infrastructure. And that is what IAC, infrastructure as a code, brings to bear for you. Now, we move from there, we move to operation, where we do virtualization and containerization. And then we go to monitoring. And then you talk about monitoring the other time, using your what? Your instance and event monitoring systems, right? You monitor for bugs, you log every instance. And if God help you, the person that wrote the code did not even do audit trail in his code. Now, when there are issues, it becomes difficult to trace where the issue is coming from. True or false? True. So all this has to be planned from the onset. You must plan all this to the smallest detail. So that you understand, everyone on the team understands what needs to be done at each level. So you're not waiting for when you are deploying to define what server structure, what is the size of the server you need, how many of that will you need? Will you need load balancing or not? Will you need this or that? You're not waiting till that time. From the get-go, everyone knows what needs to be done. Now, that is beautiful. But then, errors, security issues start showing up at the point of deployment. And that is why we said, with DevSecOps, we are leaving this. Now, this is just showing you some of the applications that can be used to achieve some of those things. So with DevSecOps, I've talked about all this. Let me just skip all this. With DevSecOps, what we're trying to mitigate is the financial implication of addressing vulnerabilities. Because the cost of fixing issues is much more than the cost of fixing it from the onset. True or false? Because it can lead to loss and lead to other issues. For example, you build an application where customers are meant to pay, and then you forgot to remove the test key, the stack API key, and you let it code and deploy the code like that. And then people started having click on it and they say select success, and then payment is successful, they get whatever they paid for without paying a dime. True or false? It can happen. I've seen it happen in several applications. I've seen some invest applications where I was able to enter the portal without logging in. Don't let me mention the name of the university. I was able to enter the application and then I just had to call the people because I had a relationship with them. I just called them. Oh, I was just checking. I was just doing something random online. Please, can you fix this? Because I was able to see result upload. I can change results. Now, but all this could have been avoided if the right thing was done from the onset. So the cost of fixing vulnerability is much more than the cost of developing security into the system from the onset. And that is why we have DevSecOps today. So what is DevSecOps? Introducing security into the development and the operational process. So you can see from this end, we have the DevOps, and it just divides the development, IT operation, and then application what? Delivery. But on this side, we have it, security coming in now, into play, and infused into the system. And that means that from the point of planning, you are talking about what are the edge cases that can be experienced for each feature that we are developing. On the login feature or login module, what are the possible edge cases that we can experience? How many persons have done maybe a programming test online before? They will give you tests that you must run some tests against the code you've written, right? These are what we call edge cases. What is the worst scenario that can happen? So from the onset of planning, you're talking about for each phase or for each application feature that we're developing, what is the worst thing that can happen? So when the developers are planning and developing, they are looking at what is the worst that can happen. Have we taken care of this worst case scenario? Are we together? So from the onset, from the get-go, you are planning that by the time we are building, what are the vulnerabilities in Apache web server? Should we use Apache at this point? Should we use Nginx? Now, what is the traffic that we are expecting? Now, what version of Apache are we using to deploy? What version of Nginx are we using to deploy? Now, the version we've selected, are there any CVE security issues that have been highlighted online? You're checking all that and listing all that, determine whatever. From the onset, you have put what we call security into every phase of the process. So everyone developing understands I have to watch out for this scenario. Everyone deploying understand that I have to test, or everyone testing understand I have to test this scenario. As a matter of fact, these days we have what we call Excel sheets, or a sheet put in different scenarios when we are testing. When we are testing, you have someone that will sit down. This is the objective of this application. So when you are testing in this edge case to make sure that it is not there. You're testing this to make sure that it is not there. You're testing that when this is done, this should be the end result. And then they will give it out to people that will test, and everyone will bring in their own reports. Testing each feature and then highlighting at each point that, oh, I've tested this and this was the result. The result is okay or not okay. If it's not okay, explain what you experience. And that is what now goes back to the developer to now work on and making the work much more easier. Because he has taken care of most of this. He understands all these things from onset. True of us. Now, because for everyone, your knowledge is limited to what you know. True of us. So I can tell you this is the feature I want. You are developing the feature based on what you understand. As a matter of fact, I might not even talk to you. I might talk to your boss. And your boss is the one that spoke to your project manager. And your project manager is relating the matter to you. And then information is lost along the way. But if all these are well defined, and I will talk about some of the tools that are used in industry today to get that done. If all these are well defined, helps to mitigate the issue of fixing all these vulnerabilities, the end of the process. So as the process is going on, everyone is checking to ensure that these vulnerabilities have been highlighted, are already taken care of. Now, looking at each of these phases, for DevOps, we say for planning stage, we collaborate on the project goals, right? That's what we're doing in planning. Talking about what is this goal, what are the requirements, and we are talking about that. But with DevSecOps, we are now talking about what is the plan with the threat modeling for security. So what are the threats as you are planning? And what model are we going to employ? As a matter of fact, we're talking about something earlier on with the first, the keynote speaker. And we're talking about, and do recovery period. Talk about recovery period. Response, yes, incident response. As a matter of fact, from the onset, you have what we call the incident response plan, IRP. Already spelled out that when there are vulnerability issues, what needs to be done and by who. So everyone knows what needs to be done even when there are security issues at the end of the day. So it's not that it is when they are coming up, let's say, oh, come. Who else do we need to call? Then you now start planning and then, oh, you're supposed to call so person. Please call him. You should join us in this meeting now. Now the IRP already defines who and who must be engaged when there's a certain kind of vulnerability in the system. Not just that. From the onset, you're defining what we call the response time objective. RTO. And then you are already defining the RPO, the response point objective. Now, what is the difference between RPO and RTO? Response point objective talk about how much backup or how often should the backup be done. How much data can you afford to lose in the event of an incident? How much data can you afford to lose in the event of an what? Incident. Yes. So, and that will define how often backups need to be done or integrated into the system from the get-go. That's RPO. Response point objective. Now, RTO, the response time objective, talks about how long can we afford to be down before we are back up if there's an incident. How long can we afford to be what? Down. Talking about the time frame. So, for example, InterSwitch, Money Point, they can't afford to be down for more than 5 minutes on a normal day. But there are circumstances that might warrant that they are down more than that. For example, I think 2 weeks ago, I was in darkness for about 3 days. Where I live, I moved from that place just 2 days ago. Now, where I was living, we're on band A. So there's light almost all through the whole day. At times 3 days, light is not off. Now, but I wanted to recharge. And I didn't know that my unit was very low until the light went off. Oh, I said, okay, let me just recharge on my phone, and then IBDC said, continue. And then for the next 3 days, I couldn't recharge. And I was burning fuel to power my generator. And God bless me, my generator is 7.5 kVA. So you can imagine how much fuel I'll be burning per hour. And you understand? But understand that for a business, they can't afford to be down. They will be down. Because I can say, oh, my value will go for a few minutes. For a business, as it's going down, the generator is coming back on. True of us. True. So all these things are defined from the planning phase. When there are security threats, what needs to be done? What security threats can we envisage that would happen even during development that needs to be plugged or blocked at that point? So at the point of coding, DevOps, you're just developing the application code. But for DevSecOps, you're talking about coding securely to prevent identified vulnerabilities. You have already defined that I can't use this plugin because there are issues that have not been fixed by the developers. I can't afford to use this plugin because there's been no active development for the past 6 months. I can't afford to use this plugin because there is no community backing up that plugin. All that will need to be considered in development phase. Now, when you get to the build phase, normally you're just compiling code and creating artifacts. But here, you are integrating automated security checks also. So as you are deploying, you're automating the checks also. It's doing a security test as it's running, as you are building. The build process is also integrating a security check on the build. The same thing with testing. You're only verifying the application functionality. But here, you are performing also security testing for the identified vulnerabilities. And that is why a QA cannot be the programmer or the developer. Because you're the one that built the system. You only be checking what you developed. True or false? There's somebody that will be giving, like your Bible will say, that will not first if the what's it called? The ridge to himself. That is why the QA persons are the one that will do the tests. And when they're doing their tests, they already have a list of what they are checking. The project we did, what we did was there was no QA. So we had to tell everybody, you'll be the one to test these parts that the backend has done. Backend, you'll be the one to test what frontend has done. This one, you have to just make do. But doing that, we gave them a list of what needs to be checked. That at the minimum, something else. But all this list must be checked. And we must see a report on that list. And then we move forward to the release. As you're preparing to release, you are ensuring that you are releasing something that is secured. So you have already tested, and what you're releasing now is what? Secure to a large extent. You deploy, and then you are establishing the incident response what? Process and procedure. So you know at this point, if anything happens, what are we doing? Who and who should get involved? I've seen cases where there was no IR response process defined. That they would have discussed, and then they now start calling me that, so can you help us check this? We've been on this for the past 2 days. In the past 2 days, you would have called me. I have a log I can check to know what is happening. As a matter of fact, every application I develop, I can still enter the application because I'm the developer, because I know how I can enter. But if that same window I created becomes exploited, then it becomes an issue. And that means that as I'm developing that window for myself, I must also think about what are the vulnerabilities I'm opening up also. And with the options, like she said. So I know, is it worth it or not? How critical is the system we're developing? And we go to operate, and then we go to monitor, and then all that. Now let me skip for want of time. Now for the planning phase, let's start with that. Now we've discussed this already. I'll just talk about the tools that you can engage in each of these phases. For example, on the planning and design phase, there are tools that, for example, the open source tools. One of it is the OWASP Threat Dragon. Now, this OWASP Threat Dragon, you can check online. It helps you in defining vulnerabilities and threats. So you can have a pictorial diagram of what is expected and what are the threats that can be expected in the system. So this can help in designing that can be shared in a group. Now we have frameworks like the Stride and the Dread. Now Stride and Dread is from Microsoft. You can check that out and look at that. So I'll just keep running through this so you can take note of some of these things. There are other ones you can still check online. just check online what are the tools that you can engage in social phase of development. You see different options coming up. Now, I said here, for example, a practical application may involve using OAuth's threat dragon to visually map out threats and what? Vulnerabilities, thereby enhancing collaboration among team members and aligning security consideration with project objective from the very beginning. So you're not waiting till it happens, but you are envisaging what could go wrong from the onset. Now you can see Stride helps identify potential threats by categorizing them into 6 types. Spoofing, tampering, and that is where the acronym came from, Stride. S for spoofing, T for tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Now, elevation of privilege is an example of what I talked about earlier on. Myself as a developer creating a window where I can still enter the system. Someone else can exploit that and use that to gain administration. But so that can lead to elevation of privilege issues. Then the dread talks about identifying the damage, potential, the reproducibility of the error or the threat, exploitability of the threat, and then affected users, and then discoverability. How do you discover the threats? How do you identify where the issues are coming from? Now in the coding phase, now you have the OAuth's dependency check that can be used. For those that write in JS, JavaScript, you have the retire.js that can be used, that can help you identify which plugin is not actively developed, which plugin has vulnerability that has been identified online. It can help you detect all this even during the coding phase, and it can highlight all this and it can identify them easily. Now, the keynote speaker mentioned SonarQube. That is there also, that's SonarQube there, that's the spelling. SonarQube. You can check all this out. You have other things like Git leaks. Now, we can also be used at this phase to also review your codes, detect vulnerabilities, and detect possible exploitation on the code. So, for the build phase, now we said the build phase involves compiling codes and packaging application. This phase includes container image scanning and secure configuration checks to ensure application integrity before deployment. And what we can do with this, we have for container scanning, we have secure configuration, all that. And some of the tools we can use, we have what we call Thriving. Now this is used for scanning your containers for vulnerability. You can scan containers, it can scan your file system, it can scan your Git repository, and it's also able to scan to check if you have mistakenly left a secret in your code. For example, you have your database password. You have an admin password already stored in the code when you are testing, and you forgot to remove. Have something you have put in the code, and that is why we use .env files, right? To store those codes, to store those secret keys, right? But it's possible to add coded something into the code. Now, some of these tools can help you detect some of these coded secrets in your codes. Now, for Clear, that is used for the static analysis of your container or your container images. Now, for the test phase involves the rigorous assessment to ensure security and performance through automated testing. You check for things like your SQL injection, check for SXS, check for different kind of vulnerabilities. And there are different examples that we can use for that. Now you have the OAuth SAP, that is the Z attack policy, proxy. You have the Trivy, you have the SemGrep, you have the CubeScape, and you have the gripe. I believe you have access to this, so you can have the list of these things when you have access to them. Now, at this stage, you are doing both the static analysis and the dynamic analysis. That was mentioned earlier on by the keynote speaker. I don't know if anybody caught that. When he mentioned that static analysis and dynamic analysis will need to be done on your application. So some of these tools can help you achieve the static analysis and the dynamic analysis of your application. Now, I've mentioned some of these things, OAuth SAP, Gatling, JMeter. These are some of the other examples you can use in the testing phase. Now, in the release phase, at this point, this is where you prepare your release notes, you prepare the application for production. Now, at this point, you should be checking for compliance with data security rules, check compliance as much as possible. So you are doing security check and security scanning on your infrastructure and every other thing. And some of the tools that you can use are also mentioned there. So yeah, you're doing IAC security checks, that's infrastructure as a code security checks. You're also doing policy as a code. Now you can use tools like the checkoff for your IAC, that is infrastructure as a code check. You can use your OPA, Open Policy Agent, for checking policy alignment. For example, you are deploying to European countries, then you must align with the GDPR. You're deploying for Nigerian market, you must align with the NDPR. At least, have we all heard about NDPR? So you must align with all that. You check other policies to ensure that all that is in place. For the operate and the monitor phase, you focus on running the application smoothly while ensuring security, typically including infrastructure management and incident response. So how do you identify issues? How do you even know that there are issues on your system? At times, there are issues that will be happening that you might not even know if there's no proper monitoring. There are attacks that we call the zero-day attack. It happens on Microsoft systems, happens on different systems. That if there are no proper checks, you might not know it is even happening. Now, if there's no system to check for anomaly, for example, we're developing a loyalty management system for a company. And we're trying to find a possible threat. And someone saying, oh, let's make sure that we check for patterns. If we talk about loyalty, you can't accumulate 1,000 units of loyalty in one day. Is it possible? 20, depend on the rules. For example, they'll say when you recharge 200 naira, you get 20 naira back. Now, if you don't see someone that is charging 20 naira and accumulating 100 naira, you start asking questions, right? Won't you ask questions? So you must have a system in place that can check for anomalies, behaviors that are not aligning with the normal patterns. So once you're seeing this, it alerts you. Once you are alerted, you can know what to do next. You can know where to check. If there are no logs, server log, and every other log, even the application log itself, it becomes so much difficult to identify where issues are coming from. Customers are complaining, we can't do this, we can't do that. Then that's when you now start putting your code, print out, or echo, or, you understand, you know how we debug now as developers. But if you have locked systems, you can and check, oh, what are the errors that are coming up? What are the things that are happening at intervals? For example, as I am now, there are some servers I deployed where we did master slave or master replica system for a database. Now, once replica. The read operations are happening on the replica, while only write operations on the master. What do I mean? When you are registering, everything you are registering is going towards the master because that is the one that has the write operation. But you want to retrieve your email, retrieve a data. Instead of going to the master, it's going to the slave. So that there's not too much load on the master. You are running a report. The report is not happening on the master. It's happening on the what? On the slave or the replica. That is distributing what? The load. Now, what happens if that replication fails? Probably at some point in time, the master stops replicating to the happen. That means every report you're generating would have issues. True or false? That means people want to log in. That means people that want to log in might have issue logging in. True or false? Because you are reading the login details from the slave. So what we did was that we had a code that we just put up. It's on my GitHub repository. I set it online and modified it to suit what I wanted. Now once it checks every 5 minutes. Now once there's no replication in the last 5 minutes, send me SMS and email. So in case I'm not checking my email, SMS would come in. And I think it has worked once. It has been done once. I started getting, I got the first one, got the second one. I said no. I called them, please check the server, check this, check that. And then I called the guys, you check this, you check this. Everybody check. Within a few minutes, we're able to resolve the issue. What happened? The slave, the master hard disk broke down. Now, imagine that there is no backup system. What would have happened? For that client, what they wanted was every 6 hours, there should be a backup. So their RPO is 6 hours. So they don't mind losing 6 hours amount of data. You can still recover because it's not so critical. Understand? But because we're able to get it on time, we're able to resolve on time. Now imagine that you don't even know until customers are calling you that, sorry, your server is down. We can't access your server. Imagine what would have happened. But because there was a system that was monitoring, in just less than 5 minutes, we got a notification that, oh, the replication is failing. And then we have to just go check, oh, master is down. So check the master. Okay, master is down, the hard disk is down. Spin up another this thing and let it go up. Now, in critical system, like he said, what we would have done is that we would have created maybe IAC, infrastructure as a code, that will spin up something when the master is down. But because the system was not so critical, that is why we're not using that. At times, you also consider the client because the client cannot pay for Amazon. So you understand that you weigh all that when you are working on the system and designing the process. Now for this, we have different tools that you can use for monitoring. We have the Prometheus or Grafana. We have the Elk stack and we have the Falco. And we have a description of what each of them would do, what are the measurable outcomes, and what is the time frame for deployment and then for other things on the system. You can see all that. Let's just run through one. Prometheus collects metrics. Grafana visualizes them for real time. So they work hand in hand. Prometheus is collecting the metrics, while Grafana is what? Putting it into pictorial view for you. Pie charts, graphs, and the rest. Now, this improves incident response time through real-time metrics and what? Alerts. So you're getting updates as soon as possible. So you are not just talking about deploying and then leaving it. We're talking about how do we know when things are not going the way they're supposed to go. So the implementation can take up to 1 to 3 weeks, depending on who is deploying and their expertise. You can just go through the rest when you get the note. Let me see, how much time do I have? Now, for integration, it talked about CI/CD, continuous integration and continuous what? Development. CI/CD. There are tools, several tools you can use for that these days. Several tools. Example. Sorry. Jenkins, yes. GitHub Actions, thank you. We'll talk about that in the next session. Circle CI, and so many other ones. So you're using that to automate the process of integration. So you're not waiting. Now you can do this for different things. I've used GitHub Action for mobile app deployments. I used Expo and React Native, and then once I push to a branch on my GitHub server, it initiates the build process and initiate the testing. Once testing is successful, it pushes it to the Play Store and Apple Store. And all I have to do is just go to the Play Store and then do the other things that need to be done. That has to be manual. Those ones can be automated. But instead of me waiting to be the one initiating build, initiating testing, it does the testing, builds, and then push to Play Store, pushes to Apple Store. You just go to Apple Store, just set it up, define the version number, and deploy, and then wait for approval. So you can use it for anything. Now, I'm not talking about even coding alone now. All these things apply to different aspects, even for network engineers. For example, your infrastructure as a code, and you deploy it to GitHub, where others can collaborate with you. You work together on it. There's versioning. We'll talk about that in the next session. You work on that, and then once you push to a particular branch, everybody, the system just goes into action. You don't need to do anything. Once it's on dev, you can say when it's on dev, push to your development server. When it's on production branch, push to your production server. When it's on testing, push to the testing server. And all that will be done automatically without you raising a finger. What you have to do is edit, push, merge. Once it's merged, you are good to go. So all this can be automated. So we have CI/CD orchestration tools, we have configuration management tools, and we have issue tracking tools. And some examples are mentioned there. For the CI/CD automation, we have the Jenkins, GitLab, CI/CD, GitHub Actions like we mentioned, and then other ones. For configuration management, we have Ansible, we have Chef, we have Puppet. For issue tracking, you can use Jira, you can use Redmane, and other ones like that. And you can see that how does it assist you to get things done. Now, even GitHub has issue tracker, right? That's issue tracker. I've worked on some open source projects. For example, I know this React Native Paystack API SDK. I've added some things. I'll just go through. I just say, oh, people are having this issue. I just try to I can solve it. I solve it, push it, and then resolve that issue, and it's closed. That is beauty of open source, because people can come together, work together to solve issues, and it saves time. Vulnerabilities can be blocked early on. Now, what are the benefits of DevSecOps? Now, unlike what we're asking that we want to delay, now it's actually saving time, because you're not waiting till the end to discover vulnerabilities. You're already building solutions for identify vulnerabilities from the onset, because at the planning stage, you've already discussed what are the possible threats and vulnerabilities that can be in the system. And as you're moving along, you're already taking care of each of that every point along the way. So in the actual sense, you're saving time, not wasting time. Moving to DevSecOps. Now, it reduces vulnerability to a large extent, because everybody has come together to rub minds together during the planning phase to identify issues. So at the end of the day, what you'll be detecting will be minimal. Because at the testing phase, people already have a list of what to check, and they're checking that already. Now, it improves collaboration and fosters a culture of shared responsibility for security, enhancing team dynamics and communication. So it's not just about the red team or the blue team or the gray team. Everybody is working on security from the get-go. Yes, your red team might try to discover, but they already told you what could go wrong, what to do, what to check out for. Now, there are several benefits of DevSecOps. These are just some of them that we have highlighted here. Now, understand the common challenges that could come up. Now, the first challenge is culture resistance. Most times, people are not open to change. I just want to get my things done and leave it and go. The UI UX guy is not ready to wait. The front-end guy is not ready to wait for any other person. Back-end guy wants to do his work and then just leave it and go on. But if everyone can work together, it will foster understanding, reduce friction. But culture resistance is a challenge that comes up. Complexity of tools and processes is also a challenge. People say, oh, the learning curve of the tool. But then, once you get a graph of it, you have an asset. Now, skill gap among team members. How do we overcome all this? Is address initial investment concerns. Manage tool sprawl effectively and reduce false positive in security tools. All that can be taken care of. So what are the key takeaways from this session? Now, essential insight for effective implementation. There must always be a culture shift for anything to work. As long as you believe that it cannot work, then there's a problem. But when you weigh the advantage vis-a-vis the challenge that may come up in the future, I think you might be on the safer side with the advantages. So there must be collaboration and everybody must take responsibility for DevSecOps to work. It's possible you say, yes, you're going DevSecOps way, and then someone is not doing his work. You're putting the load on someone else in the next phase. So everybody must take responsibility because from the onset, that is already defined. Now, it helps us to integrate security early and focus on high impact areas. So you're able to identify what identify what are the high impact vulnerabilities. You can plug that. What are even the medium impacts, the low impacts? I can always plug that. Now, most of the tools that we use, most of them are open source. That's the beauty of this. There are some that are paid actually, but yet there are still some that are open source. But we cannot do away with continuous learning. Everybody has a role to keep developing themselves. If you stay in a place for 6 months, before you know it, everything is gone. Like he was saying, you can use AI for so many things, but AI will not fix the place of you understanding the basic principles. You can use AI to write codes. I teach people how to use AI to write codes. I've had UI UX guys design interfaces, and then I just instead of me saying, oh, front end, come and do this design, I just describe that design to Copilot, and Copilot will give me that design even better. How to describe? But description is just 2 paragraphs. You must understand prompt engineering. Because I've had some of my guys also try it and then they say, no, it's not working, or guys, it's not working. So you can't do away with learning. If I show you an interface that we designed, I will show you what the UI UX guy designed, and then after I describe to AI what AI brought out, you open your mouth and say, wow. What AI did was better off than what he designed. Not because AI is very good, but because I was able to explain the nitty-gritty. When you click on this should happen. When you do this should happen. When you do this should happen. Now I want a description like this, and I explain that, and then even what I did not put there, it was adding it because I said like. So all that learning, the place of learning, and that is why we have a workshop like this. The place of learning cannot be overemphasized. So you must iterate and keep what? Improving regularly. So DevOps is a culture shift. You shift to the left, and then you automate to the what? To the right. So you're not staying in a place, you're not shifting to the left. So as you shift to the left, you are still going to the right. So it's a shift. It's not static. Whatever you know today, tomorrow is changing. As you're developing security, some people are sitting down and what they're looking for is what? Vulnerabilities. So open source is your friend. But then you have to be careful. Also check. Check what is the community behind that open source application. Check how much activity is going on that application. When people raise issues, how soon do they get response or resolution to those issues? You start small. So don't go big. You go big. How do they say it? You start small. No, they say you go big, go something. I think there's a saying like that. No, there's one. I'm trying to remember. Okay, go big or go home. You can start small. Start from where you are. You grow. You grow into it. So maybe you can even take it phase by phase. Oh, from the planning, let us plan this now. Let us use these tools. Let's identify the tools that we're using. Not all the tools, because jack of all trades become master of none. Continuous learning is vital. I've said that. It embraces security as a principle. Now, as I begin to close, okay, I've talked about all this. Talked about embracing DevSec, open source tools. Now, let me ask if you have questions. Questions, and questions. Thank you very much for your time.